Before we can study the equations of lines, we need to understand slope. Okay? So slope is basically measuring how steep the line is and whether it goes up or down. Okay? A positive slope means it goes up. A negative slope means it goes down. Zero slope means it's horizontal. An infinite slope or an undefined slope means it goes straight up and down. Okay? So slope, how we define it mathematically, is the rise over the run, the change in y over the change in x. That's what this means, change in y over change in x. And the change means difference. So the second y coordinate minus the first y over the second x coordinate minus the first x coordinate. Okay, that's usually if the points are listed that way. Okay, so you might have something that looks like this. Okay, there is the graph, and the line would look like, go more, make it a real Cartesian plane. The line could go like this. It's going to have a negative slope. Okay, so if you take a triangle on it with a 90-degree angle in it, then this would be the rise, and this would be the run. Okay, if you take 2 points, there and there, well, you can make a triangle from there and there. Okay, so that point is x1, y1, that's x2, y2 maybe. You could have it the other way around. And here is the difference of the y's. Okay, so y2 minus y1. That would give you a negative value because that y value there, okay, is smaller than that y value. So if that was a 2 and that was a 5, then 2 minus 5 is negative. That would give you a negative rise, which is appropriate because it's going down, okay, from that point to that point. So we're going from x1, y1, point 1 to point 2. Okay, the run, well, that's the difference in the x's. So there's x1, x2, or sorry, yeah, x2. So say that's a 1 and that's a 4. Well, then the run is going to be this, which is going to be x2 minus x1, and that would be 4 minus 1, which would be 3. And that's appropriate because you're going forward 3, so a positive run and a negative rise. Now, if you're going from this point to that point, then you would be going backwards. So you'd be going a negative run and then a positive rise. It will all sort itself out. Okay? So in this one, if you use 4 and 1, the run is 3. If you use 5 and 2, the rise equals negative 3, and the slope equals rise, which is negative 3, over run, which is 3, negative 1. Okay? So here's some instructions. Okay? So to determine the slope of a line from a graph, pick 2 points on the line. Move horizontally from one point until you are directly above or below the other point. Okay? So that's kind of what we're doing here. We moved horizontally till we're directly above or below the second point. Okay, we're above it. The distance is the run. So that distance from there to there is the run. Okay. If you moved left, it's negative. If you moved right, it would be positive. Okay. The rise is the distance that you move up or down to hit the other point. Down is negative. Okay. So we went from here to here, that's the run. The rise is how far you go down till you hit that other point for this, so it's going to be negative. If the line went that way, it would go up, it would be positive. Okay? The slope is then the rise divided by the run. So that's on a graph. Okay? So that's basically how you find it from a graph. from 2 points, if you got them, just like we got here, you're going to get the rise from doing y2 minus y1, it's the rise, and the run from doing x2 minus x1, x2 minus x1, that's the run. Okay? It has to be from any 2 points on the line. This one's kind of easy because you actually have 2 points that are on the axes. If you knew exactly what they were, that would make it really easy. We don't, so we're not too worried about it. Now, from a table, okay, if you've got a table of values, calculate delta y and delta x and divide them out to get the slope. So delta y over delta x, remember, is just rise over run. That's the change in y over the change in x. Okay? So let's take a look at a couple of examples here. Okay. So example 1 here. Take a look at it. Okay, so we want to find the slope of a line that goes so from the graph of line to the origin. Okay. So it's got to go through the origin. So we know 2 points on here. So if you've seen this before I did the answer, basically you've got the origin as a point, and you can see clearly on the graph that that's going to be another point. So you highlight it. This is also another point. Okay? So you could do this triangle here. It's a 90-degree triangle with 90 degrees right there. There's run. The run could be -2. Oh, sorry. Rise was, you can drop 2. You can go the other way around. You can rise from that point down -3 and then run +2. So there's the rise and run. Okay, if we're going this way. And that becomes -3 over 2. Okay, so we've got this here. So rise over run is -3 over 2. From this side here, you could pick the 2 furthest points. The run is then 4. You can count it out. The rise is -6. And you can calculate it here. -4 over, or -6 over 4. And that reduces to -3 over 2. Okay. So the second example, so the line that does not go through the origin. Okay. So if it doesn't go through the origin, and you can't actually pick out 2 clear points on the axis, you just pick out 2 other points, and any 2 clear points on there. Okay. So if you pick these 2 points, you got the run is 3, the rise is 4. Okay, you can see that. 4 over 3. If you pick these 2 points here, you can see that the rise is 8 and the run is 6. 8 over 6 reduces to 4 over 3. Okay. So here we have a line, okay, example 4. We've got a line through 2 points. One of them happens to be the origin. So you're given the points, okay? Just plug them into the formula. Call that x1, y1, x2, y2. Plug them in. 5 minus 0 over -2 minus 0. Okay? Which ends up being 5 over -2 is the slope. The picture of that is right here. If you plotted them, there's 0, 0. There's -2, 5. And that's what it looks like. Okay, so there's the rise. Okay, if you're going from A, which is this point here, to that point, you're then doing a run, which is -2. You're going backwards, and then you're rising 5. Okay. Now, another example here is a line through 2 points. One of them is not or neither of them are the origin. Okay, but one's on an axis. So, again, y2, y1, so 5 minus 0, x2, x1, -2 minus 3. You simplify that, that becomes 5 over negative 5, which equals negative 1. So the slope is negative 1, which means it goes down. In both cases, the last example, it goes down too. So here is a graph of that. So the rise, you're going from this point here, that's the first point, to that point. Okay? So the run then is you go across. How far do you go across? You go negative 5 across. You go 5 back, so it's negative 5. And then you go up 5, rise 5. Okay, if you're going from point A to point B. Okay. And the next example, okay, through these 2 points, neither of them are on the axis, neither of them the origin. It's getting a little more complicated, it's okay. So you plug them into the formula. x2, y2 again, x1, y1 here. Okay, 5 minus 5 over negative 2 minus negative 6. Remember, minus and negative is adding. So you've got that. 5 minus 5 is 0. 0 over anything is 0. So the slope in this one is 0, which means we have a horizontal line. If the slope is 0, there is no rising or falling. So it is going to be a horizontal line. Okay, and there's what the graph would look like for that. Okay, and this next one is a line through the points negative 2, 0 and negative 2, 5. In this case, the x coordinates are the same. The last case, the y coordinates were the same. Okay, so the y coordinates were the same, and it's a horizontal line. It didn't go up or down. The x coordinates are the same, means it's going to be a vertical line. It doesn't go across. It's going to have an infinite slope. Okay, so basically here's what we got for the slope. You do 5 minus 0 over negative 2 minus negative 2. Okay, so 5 minus 0 is 5. Negative 2 minus negative 2 is plus. That becomes 0. You cannot divide by 0. Okay, it is undefined, which means you basically have a vertical line or an infinite slope, and the line looks like that. There's the 2 points. Okay. Now, if we had a table, okay, if we have a table of values, this is how we got to look at it. So the table is the one that's in black, the original one there. You've got to calculate out the change in x. So you always do x2 minus x1, x2 minus x1, x2 minus x1, the second minus the first. Okay, so 1 minus 0, 1. 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. That's the change in x, and it's constant. Okay, it should be. Here the y, 5 minus 7, negative 2. 3 minus 5, negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. Okay, so that's the change in y. If they are both constant, then you know you have a linear relation. Okay, and you can divide them to get the slope. Here's another example. Okay. This one has a positive slope. This time the change in x is not 1 though. I made the x coordinates go up by 2. Okay. So you get the delta x is 2 and the delta y is 4. Divide them, you get a slope of 2. Okay. And that's it for slope.